Hello, trigonometry, and welcome to the video over 7.4, trigonometry equations. Give me a second, I gotta close the door. I do want to point out before we start this lesson is that you are going to need two things. You are going to need your regular blue calculator, and you will also need your unit circle. These will be the two things you'll need for this lesson. You will not need the formula sheet for this lesson. We're already done with all that. So just need your blue calculator and your unit circle. And if you do not have a blue calculator with you, never fear. There is actually a very similar calculator that you can find online. I'll show you the one I have, and this is the one I actually prefer you to use. So give me a second. So if you go to Google, you're going to look up this website. You're going to go eeweb.com/tools/calculator. And it's going to bring you to this website. And basically, you're going to scroll to the bottom, and it'll have an online scientific calculator. And as you look at it, it basically has all the functions that a normal calculator would have in our classroom. So like, say, for example, you wanted to find sine of pi over 6. Well, you press the sine button, and you do pi divided by 6, close parentheses, and then press enter. And there you go. And also, if you needed to do inverse, here is A inverse. Basically, A inverse is A sine is the same thing as inverse sine. So let's say this is basically, let me refresh that. If you need to do an inverse function, A sine is the same thing as sine inverse. So say you wanted to find inverse sine of 1/2. That's how you would find it. And probably something else, I probably should teach you how to do, how to change from degrees to radians. So if you go up here, this will be the little button that tells you radian, degree, or grad. So if it's here, it's degrees. GRD, we don't do GRD. And then there, it would be radians. So radians, degrees, don't ever use that. Radians, degrees, don't use that. That's how you would use that in that case. For now, let's keep it in radians. And if you need to change it to degrees at any time, that's how you do it. Okay? You got everything you need. You got your calculator. You got unit circle. Now let's go on to the lesson. So, before we start, got a little bell ringer for you. Let's say you're given that cosine of x plus 2 is equal to 3, and we want to find out if this is a good solution for it. And the best way you can figure that out, take that 0, plug it in for x. So in other words, we're going to see cosine of 0 plus 2, and we're going to figure out if it does equal 3. So then if you go to your little handy-dandy calculator, let's do cosine of 0, assuming it's in radians, and it's going to give you 1. So in other words, you'll do cosine of 0 is equal to 1, and then 1 plus 2, which indeed does equal 3. So thus you would say that x equals 0 is a solution. And these are the type of equations that we're going to be dealing with. Basically, we're going to be finding solutions to satisfy given equations that involve trig functions. Just to give you a preview of what this lesson is going to be covering. So I'm going to go ahead and hide this. We don't need to see that anymore. So far in this chapter, in chapter 7, we have worked with identities, and they have been used either to simplify trig expressions in order to solve them, or to verify other identities. In this section, and specifically 7.4, we will be looking at given equations and determine all the values or angles that will make the equation true. Basically, just like in the bell ringer, we'll be given an equation, and then we need to figure out what solutions make it true. And for this case, as I told you before, you will need your calculator. And if you don't have a calculator, just use the one that I showed you. And again, have your unit circle handy. You will need your unit circle. You'll be shucks out of luck without it. So with that, let's move on. So here are some typical Hawks program examples that we'll have to address. For these questions, determine if the given value is a solution to the equations. So, give me a second, I gotta take my jacket off. So for the first example, we're given that 3 times tangent squared x is equal to 1, and we need to ask, is this solution going to work for that? And this is how we'll do it. Basically, what's going to happen is we're going to do 3 times tangent x, or in this case, the x will be 7 pi over 4. And also remember that the tangent is squared, basically saying you're going to take tangent of 7 pi over 4 and then square it. Basically, this is literally a plug and chug scenario. So now, you guys know how to use your calculator. I'm going to go ahead and use my hand calculator. So let's go ahead and do this part. Let's do tan of 7 pi over 4, and let's see what that gets us. Tan of 7 pi divided by 4. And also, make sure you are in radians. I apparently was not in radians. I was in degrees. Okay? Because again, 7 pi over 4, that's a radian angle. So now let's do tan 7 pi over 4 in radians, and you should get -1. So let's go over here. So 3 times tangent of 7 pi over 4, which, as you saw in the calculator, that gives you -1. And then just simplify from there. So 3 times -1 squared, but -1 squared just turns out to be +1. And now you just got to do 3 times 1 over here, which will give you 3. And wait a minute, that's not supposed to equal 1. Oh no. That basically means 7 pi over 4 does not work. We tried, it didn't give us 1, so 7 pi over 4 is not a solution. And that's what you would put in the Hawks program. This is not a solution. That's all you got to do. And now let's do the same thing for the second one. Here we got 2 cosine of x minus 2, and we want to see what will make that equal -2. And the value we're going to test is 3 pi over 2. We're going to plug that in for the x and see what happens. So in other words, we're going to be doing 2 times cosine of 3 pi divided by 2, and then we're going to subtract 2. And we're going to see if this ends up equaling -2 in the end. So, in your calculator, go ahead, find out what cosine of 3 pi over 2 is. Let's go ahead and do that. Cosine of 3 pi divided by 2. Again, in radians. And you should end up getting 0. That's nice. Give me a sec. Gonna make some more space here. Okay, so that becomes 0. Now we just got to simplify from here. And 2 times 0 will give you 0. And then 0 minus 2 will end up giving you -2, which, of course, is exactly what we wanted. We wanted it to become -2, just like it says right here. Thus, 3 pi over 2 worked. So then you can say, yes, this function is a solution. Easy as that. So for these examples, you're literally just plugging and chugging. And if it works, you say, yes, it works. But if it doesn't, you say, no, it doesn't work. It's easy as that. You literally plug and chug. Let's do a couple more. So here, we're going to do the square root of 3. And we're going to multiply that by secant of x. But in this case, our x, we're going to try our x to be pi over 6. So let's put that in for x. And somehow we want this to try and equal 2. Now, some of you are probably facing a dilemma here because secant secant is not in your calculator. You only have sine, cosine, and tangent, not secant. So this means we gotta use its twin. So in other words, what you're gonna do, instead of secant pi over 6, you're gonna take its twin and flip it. So in other words, it's gonna be 1, I can't write this right. So 1 divided by its twin, which is cosine of pi divided by 6. And then we're going to see if that equals 2. Okay, so going to let you know this might become a decimal, but we'll see if it works. So we're going to do square root of 3, and then we're going to do 1 divided by cosine of pi over 6. So cosine of pi divided by 6, and that's going to give you a really nasty decimal. Now, I want to warn you here. Do not round the decimal. Whatever you do, do not round the decimal. And the decimal we're going to get is going to be 0.866025,404. That's what we get so far. And then let's continue the rest of that problem down here. I'll erase it later once we get to the second problem. Now, the next thing you're going to have to do is once you have that, you're going to do 1 divided by that decimal. So in other words, 1 divided by that decimal. And again, do not round any of this. Do not round until you get your final answer. And when you and there you go. When you do 1 divided by the answer, you're going to get this: 1.154700538. That's what you have so far. And then last but not least, once you have this long decimal, you're going to then multiply it by root 3. So take that number, multiply it by the square root of 3. And in your calculator, you'll end up getting that multiplying these will give you 2. And guess what? That's exactly what we've been trying to get. We got that it is 2. And that is what we wanted. So boom, you will say that this is a solution. You guys see why I didn't round? If I had rounded this and then multiplied by root 3, I would not have gotten 2 as my answer. I had to use every single decimal number. If I didn't, this would have been like 1.999998 something, which would not have equaled 2. So please do not round your decimals. Not until the very end. Okay, so that takes care of that one. Now let's move on to the final one. Here we got cosecant to the 4th minus 2 cosecant squared equals 0. And we're going to be testing 3 pi divided by 2. And in this case, there's 2 trig functions we're going to have to plug that into. So let's just go ahead and rewrite all of that so we know what we're working with. Here, we're going to do cosecant, and inside the x, we're going to put 3 pi divided by 2. And since it's being raised to the 4th, you're going to take that answer and take it to the 4th power. Then you're going to do minus 2 times cosecant. And again, the x is going to be 3 pi divided by 2. And notice how the cosecant is squared, so you're going to find that answer squared. And we're going to see if this will all equal 0 or not. All right, so let's simplify this down. Well, to start off, you realize here, if we try to do cosecant in our calculator, it's not going to work because we don't have cosecant. We only have sine, cosine, and tangent. This means, just like before, we're going to have to use the twin. And remember, its twin will have the opposite letter in the front. In this case, its twin is sine. So take its twin, flip it, and that's how we'll find that answer. 1 over sine 3 pi over 2 to the 4th. And we'll go ahead and do that over here as well. So 1 over sine 3 pi over 2, and that's all going to be squared. All right, now let's get our calculators out. Let's start cracking. Gonna get a little more space. Here we go. So let's first figure out what sine of 3 pi over 2 is. So 1 over whatever sine of 3 pi over 2 is. So sine 3 pi divided by 2, put that in your calculator in radians, and that's going to give you -1. Ooh, that's nice. No decimals. Let's go ahead and do that over here for this one. So 1 over sine 3 over pi, or sine 3 pi over 2, and that's just going to become -1. All right, simplifying from here should be easy. So over here, 1 divided by -1 is just -1, all raised to the power of 4, minus 2 times 1 divided by -1 is -1, and that's going to be squared. And we're going to see if that equals 0. Simplify the rest from there. -1 to the 4th in parentheses, that should give you a +1. And then minus 2 times -1 squared in parentheses, that will make that a +1. Simplify from there, 1 minus 2, which gives you -1, and that does not equal 0. Oops. That basically means that 3 pi over 2 does not work, so it is not a solution. Okay, I think you got the hang of these examples now. Basically, you'll plug and chug to see if it works or if it doesn't, and you'll say at the very end, yes, it is solution, or no, it's not. And now you also have some examples where you'll know what to do if you ever need to use a twin to calculate. All right, that's the easy stuff. Now let's move on to some other things. So, before I start on the next example, I need to recall some information that might be useful. So let's say I give you sine of the angle and it's equal to 1/2. And let's say I need to get the angle by itself. In other words, I need to get rid of this sine somehow. And if you remember, the best way to get rid of sine and to make it cancel out is to use its inverse. And that's what would make the sine would cancel to both sides. So then all you'd have left over here is theta, and you just need to find sine inverse of 1/2. Now, if you're using the calculator that I'm showing you, you're going to be using the function a sine, which is the same thing as sine inverse. So when you put that in, you'll do a sine of 1/2, and it should get you a decimal. I'll go ahead and calculate that as well. So sine inverse of 1/2. And you should get that theta is going to be approximately 0.5236 if you round. Now, I need to show you this inverse function because it's going to be very crucial in the upcoming examples. So in this example, let's say we have a rock that leaves a slingshot an angle of theta in reference to the horizontal. The initial velocity is v sub 0, 97 feet per second. Don't worry about the v sub 0. It's basically just a symbol for the velocity or speed. And then the rock's going to hit a target 276 feet away. Find one value of theta if the range of the rock is given by this equation. Now that was a bit of information given at you. Before I start solving the equation, I'm going to give you a visual of what exactly is happening here. So we know that we have a slingshot. So I'm just going to do a quick sketch of what a slingshot could look like. And apparently we are also going to be trying to hit a target. And some other information we know is that the target is going to be 276 feet away. We also know that whenever this rock leaves a slingshot, and when it goes to hit the target, apparently its speed approaching the target is going to be 97 feet per second. And apparently it's also telling us that when we pull this slingshot, we're going to be pulling it at some angle in relationship to the ground. I don't know about you, but this is kind of making me think of Angry Birds. How they have you take that slingshot and angle it so that you hit a green pig-like target over here. I mean, it's a horrible sketch for a pig, but I think you guys get the gist of it. So this is basically just a drawing of everything we have and basically the scenario that we're dealing with. And what we're trying to find is we want to find what angle would we have to pull the slingshot at so that we perfectly hit the target that we're trying to hit. That's 276 feet away. And they are telling us that the formula that we'll need to use is right here. And, well, if you notice, we got b sub 0 right here, and that's where our velocity is going to go, 97 feet per second. And over here they have an r. Just so you know, r does not mean radius. They're telling us that the r is actually the range of the rock. Or in other words, basically how far we need to reach for our target. So the range is actually going to be the distance, 276 feet. And then all that's left that we have to do is, in order to find the angle, we're going to be solving for this angle. So in other words, it's kind of a plug and chug problem, to be honest. And that's what we're going to do. So now that you have a visual of what's happening and how we're going to be solving it, I'm going to go ahead and erase what I've drawn here, and I'll show you how it's done. All right, so let's plug in the information that we talked about. For the range, that's going to be 276. And then we're going to do 1 over 32, and that's going to be multiplied by the velocity squared, where our velocity is going to be 97. And then all this is going to be multiplied by sine of 2 theta. Okay, so let's take this one step at a time. And for now, let's just simplify what we can. So for example, I'm going to first go ahead and do 97 squared. So 276 equals 1 over 32. Multiply that by 97 squared. 97 squared, which should give you 9409. And that's still going to be multiplied by sine of 2 theta. And another way I can further simplify is I'm going to go ahead and do 1 divided by 32, and I'm going to multiply that by 9409 to help simplify the problem. So 276, and if you do 1 over 32 times 9409, you should get this, 294.03125. I did not round that. Please, please, please do not round that. And all that's still being multiplied by sine of 2 pi. Okay, we simplified what we can. Now our objective is we need to get this theta, or the angle, by itself. And I'm going to first start by getting rid of this number. Now, a lot of you are probably tempted to try and subtract that entire decimal to both sides. And I'm here to tell you, please do not do that. Do not do that. Do not subtract. Well, why not, Miss Shulin? Why can't I subtract? Well, because if you look closely over here, this number is being multiplied. And to get rid of it, you have to do the opposite operation of multiplication, which is division, not subtraction, division. So 294.03125 will be divided to both sides. So over here, I'm going to do 276 divided by 294.03125. And yes, it's going to give you a nasty decimal. And yes, you will have to write out every single decimal. So let's do it. 276 divided by 294.03125. Just making sure I got that written right. Yes. And that should give you 0.9386757736. Again, do not round. Write out every single decimal number. And then on the right side, all we have left is sine 2 theta. Now, before I continue, I need to bring something up that I forgot to mention. The instructions say that you could use degrees or radians for this answer. Now, before I continue, I'm going to ask that for now, go ahead and set your calculators to radians. Make sure your calculator is in radians. I'm going to give you the radian answer first, then I will show you the degree answer. But for now, go ahead and put your calculator in radians for now. Okay, so your calculator's in radians. Moving on to this question, I still got to get the angle by itself. The next thing I have to get rid of is sine. And remember, to get rid of sine, you got to do sine inverse to both sides. So sine inverse to both sides, the sines here will cancel. So on this side, all you'll have left is 2 pi. On this side, you'll do sine inverse of this entire decimal. So sine inverse of that decimal. And you should get this, 1.218769345. Oh no, check that real quick, 218769345. And that is going to be equal to 2 of the angle. Now here you're basically almost done. We almost have our angle by itself. The last thing you need to do is to get rid of the 2 by dividing. So when you do that, you'll have that your angle. Do this whole thing, do all that divided by 2. And you should get this, 0.6094. Now that we've reached our final answer, now you can round. Only round at the final answer. And that is what your answer would be if you chose to answer in radians. If you did this in degrees, this is what your angle should be. Your angle should be 34.9152 degrees. If at any time you answer a problem in degrees, please do the symbol. If you get the number right, but if you forget the degree symbol, the Hawks program will count it wrong. And trust me, no one likes it when that happens, when you do all the work and then you miss it just because of the degree symbol. So please don't do that. Please, please. If you ever do degrees, please put the degree symbol. Please and thank you. So there you go. If you ever shoot a slingshot and if your target's 276 feet away, make sure you pull that slingshot at 34 degrees and that should hit your target. I'm basically teaching you how to master, what's the name of the game? Angry Birds. I'm basically teaching you how to defeat Angry Birds with mathematics. Nice. I'll do one more example like this, very similar, then we'll move on. So same equation, same problem, only this time the velocity is 81 feet, and this time the target is 103 feet away. So let's use that information and plug it into the equation. So our range, or our distance, is going to be 103. And then we're going to do 1 divided by 32, and that's going to be multiplied by the velocity squared, or your velocity is going to be 81. And that's still going to be multiplied by sine of 2 theta. Now from here, let's go ahead and simplify before we start complicating things. Let's go ahead and first do 81 squared. 81 squared, according to our calculators, is going to give you 6561. And that's going to be still multiplied by sine of 2 theta. Simplify some more. Let's go ahead and take this number, and we're going to multiply it by 1 over 32. And when you do that, take that number and multiply it by 1 over 32. You should get 205.03125. And that's going to be equal to sine of 2 theta. Hang on, I got to check something real quick. 294. Okay, never mind. Sorry. I had to check something. We're good. Okay, where was I? Okay, here we go. Back to where we were. Okay, something's going wrong. Okay, back to it. Okay. So now we need to start solving for theta. Best thing we can do right now is let's divide, not subtract, divide 205.03125. And we're going to do that to both sides, 205.03125. Okay, let's go ahead and do that. So 103 divided by that answer, and we're going to get 0.502362445. Again, do not round. And that's still going to be equal to sine of 2 theta. Because this already canceled out, and sine 2 theta is the only thing we have left right now. Okay, it's over. Okay? So now for this example, I'm going to go ahead and change my calculator to degrees, just so you see what it's like to get a degree answer. So go ahead, change your calculator to degrees, and then we'll move on. So now from here, I need to get rid of sine. So I'm going to take sine inverse of both sides. There we go. Sines will cancel over here. Now let's do sine inverse of this angle. Okay. Give me a second. 103 divided by that answer should give you that. And now we need to do sine inverse of that answer. And you should get this. You should get 30.15642.156. And all of that is still going to be equal to 2 theta, because that's the only thing we have left is 2 theta. Now we're basically almost done. You just need to divide all that by 2. So divide all that by 2, and you will get your degree answer. Your degree answer shall be 15.0782. Put it in degrees, because again, this is the degree answer. And out of curiosity, if you wanted to see what the radian answer was, give me a sec. If you wanted to see what the radian answer was, the radian answer would have been 0.2632. The Hawks program will accept either or, the degree answer or the radian answer. You don't have to do both. But if you do degrees, just remember that degree symbol. You're going to be very mad if you do forget it. So with that said, we are done with that example. Let's move on to the next topic. Now, before I start on part 2, I want to do another bell ringer. Let's say I have sine of x equals 0, and I want to see which of these solutions work. So I'm going to plug in 0, I'm going to plug in pi, and I'm going to plug in 2 pi. See what happens. So sine of 0, sine of pi, and sine of 2 pi. If you do sine of 0, you end up getting 0. So that means this one worked. If you do sine of pi in the calculator again, you'll get that as also 0. So that works too. And sine of 2 pi, you will get the same thing if you plug that in. So all 3 of these end up working. And this is due, if you look at that unit circle, since it's periodic, or since the unit circle allows us to do multiple loops, it's actually not unusual for a trig equation to have more than one solution. Basically, I'm just repeating what's on the board right here. So from here on out, you are going to need your unit circle. So go ahead and find your unit circle, have it handy. You will need it for the rest of this lesson. So with that said, you have your unit circle. Let's approach some problems. So here's an example in the Hawks program. It says use trig identities, algebraic methods, and inverse trig functions as necessary to solve the following trig equations on the interval from 0 to 2 pi. So in other words, basically it's saying that for that equation, we're going to look at all the angles from 0 all the way to 2 pi, and we're going to be seeing which solutions work, which ones don't, etc., etc. So make sure you have your unit circle handy. So that's what the instructions is saying. From 0 to 2 pi, we're going to be finding all the solutions that make this true. Now, and also, I do want to point out, we will want the radian answers. So for this problem, I would first recommend, let's get the cosine by itself. That will be our first objective. So in other words, I'm going to do the easy stuff first, and I'm going to subtract 4 to both sides. So that's going to give me negative 8 cosine of x equals negative 4. Now the next thing I'm going to do to get cosine by itself, I'm going to have to get rid of that negative 8. Now I'm going to tell you, if you try adding 8 to both sides, you are wrong. But Miss Shulin, that's a minus 8. I'm supposed to add to both sides. Wrong. That's not minus negative 8. That's multiplying negative 8, which means if it's multiply, the opposite is division. So you divide negative 8 to both sides, and you'll get that cosine of x is equal to negative 4 over negative 8, which, of course, if you simplify, that's going to give you cosine of x equals 1/2. So our main objective, we need to ask ourselves, what x values will equal 1/2? Or more specifically, not what x values, we want to find what angles will equal 1/2. Will it be 30 degrees? Will it be 90 degrees? We don't know, not yet. But we can take a look at our unit circle and find out. So remember with our unit circle, the way that it's labeled is it always shows you the cosine answers first and the sine answers second. So we're going to look at this unit circle, look at every cosine part, and find out where cosine is equal to 1/2. And if you look right here, we have cosine equals 1/2 right at 60 degrees, or pi over 3. Let's keep looking. Here, 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 here. Boom, right here. We have cosine equals 1/2. So that's another answer at 300 degrees, or pi over 3. And nope, nope. Okay, we've done a full circle. So these would be the two answers that would satisfy. Now, which one do we put? Do we put the degree answers, or do we put the radian answers? The instructions specifically tell you radians. So then for the Hawks program, you'll put that your solutions are pi over 3 and 5 pi over 3. That is what you would put in the Hawks program. You would put pi over 3, comma, pi over 3. Please put a comma. And that's it. Basically solve for your trig function, use your unit circle, and go from there. And then that's it. We'll do a few more examples like this just so you get familiar with it. So now, same thing. We're going to find all the solutions from 0 to 2 pi. And let's first get the trig function by itself. So first, I'm going to subtract 5 to both sides. So we're going to have 5 root 3 times cotangent, and that's going to be equal to -5. Then, just got to divide this 5 root pi over 3 to both sides. Because then again, that's the opposite of multiplication. And we'll do that. You'll get cotangent x equals -5 over 5 root 3. But I do want to mention the 5 and the 5 can actually reduce, which will leave you with a 1 on top. This will actually simplify to -1 over root 3. So now it's up to us to find out what will cotangent of x have to be, or what will x have to be to get us -1 over root 3. Now here's the thing. If you use the unit circle only works for cosine and sine. It does not work. It does not have cotangent on the unit circle. Well, that stinks, Miss Schulin. Why does a unit circle only use cosine and sine? That's not fair. But wait a minute. Couldn't we rewrite cotangent using cosine and sine? If you remember, back in chapter 6, you know that cosine divided by sine is the same thing as cotangent. So if we rewrite it like this, then maybe we could use the unit circle. So back to the unit circle. So using the unit circle, I got to figure out what angle would have me do cosine divided by sine give me -1 over root 3. Well, I'll give you a hint. You know right away that whatever you do, top divided by bottom, it has to give you a negative answer. So notice how everything in the first quadrant, if you did cosine divided by sine, you'd be dividing a positive by a positive for all three of these. And that would not give you a negative answer. So you know right away that it can't be anything in this quadrant. I also want to point out the same thing happens in quadrant 3. If you were to do cosine divided by sine for each of these, you would do a negative divided by a negative, which would give you a positive. And that's not what we want. So anything in quadrant 3 is a no-go. So now, we're left with the challenge. Which ones in quadrant 2 and quadrant 4 would give us what we want? Well, I guess we'll start off with this one. Let's test it out. Let's do cosine divided by sine. And I'm going to make some room over here to do it. So let's try this one. I'm going to do cosine, which is negative 1/2, and I'm going to divide it by the sine, which is going to be root 3 over 2. And let's rewrite this so it looks a little bit prettier. Do the top divided by the bottom. So negative 1/2 will be divided by the red, but I'm going to change that to multiplication instead. But if I change that to multiplication, my red fraction will have to be flipped and be the reciprocal. So instead of root 3 over 2, the 2 will be on top, and the root 3 will be on bottom. So then multiply, your 2's will cancel, and you'll get negative 1 on top, root 3 on bottom. And that's exactly what we want, negative 1 over root 3. So ding, 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 2 pi over 3, or 120 degrees, that will get us our answer. Now, if you look at quadrant 4, and I'm going to tell you if you do the same thing for these, that's not going to work. Now, if you look at quadrant 4, if you notice here, you basically have the same numbers. You're still having 1/2, and you still have 3 root 2. The only thing is that the negative switched. The negative is now with the sine instead of with the cosine. But if you do the math, you're still going to get the same answer, even if the negative is with the sine. So that tells you right away that this is the angle we want. And then the other two would fall through. So there you go. Those are your two angles, 2 pi over 3 and 5 pi over 3. So let's go ahead and write that down. Your two angles that are solutions to this x is 2 pi over 3 and 5 pi over 3. And that's exactly how you're going to enter it in the Hawks program, just like that, 2 pi over 3, comma, 5 pi over 3. So those might be a little bit tricky since it's not just sine or cosine. You'll have to do a little bit more division or multiplication. So please be careful with those. Now, I want you to go ahead and try this one on your own. I know you guys can easily solve this one. It's very similar to what we've been doing. Go ahead and pause the video and try it, and then resume the video and check your answers. Go ahead and do that now. All right, you should have resumed the video. If you solve for this equation, you should get that cosine of x should be equal to root 2 over 2. So then you just have to look at the unit circle and figure out which angles does cosine equal root 2 over 2. And you should get two answers within that circle. You should get pi over 4 for one of your answers, and then 7 pi over 4 for your second. And those would be your Hawks answers. Done, easy peasy. Now there's three more examples that I want to talk to you about real quick before we move on to part 3. Now for these 3 examples, let's approach them just like we've done before. So for this one, we got cotangent minus 1 equals 0. Let's go ahead and get the cotangent by itself. So I'm going to add 1 to both sides, and I'm going to get cotangent of x equals 1. Now again, this cotangent is not on the unit circle. We have to rewrite it in terms of sine and cosine. And cotangent, since it starts with the c, its top will start with the c. So, in other words, we need to figure out if we do cosine divided by sine, when is it going to equal 1? And if you go back to the unit circle, I'm going to go ahead and erase all this. So again, we need to find out, when does cosine divided by sine, when is that going to equal a positive 1? Well, I'm going to tell you right now, it's not going to be quadrant 2. Because if you do cosine divided by sine, you're doing a negative divided by a positive, which gives you a negative. But we want a positive one. So nothing in quadrant 2 is going to work. Also here, you got a positive divided by a negative, which will give you a negative. That's not what we want. So nothing in quadrant 4 is going to fit the bill. So we want to look for something in quadrant 1 and quadrant 3. Now, you guys know the rule that if you take anything divided by itself, it's going to equal positive 1, right? I bring that up because look at the angle right here. Here's cosine, here's sine. And if you were to take that and divide it by itself, wouldn't that follow the same rules as this? If you're taking anything divided by itself, you're just going to get 1. And that's exactly what we want. We want the 1. So in other words, that's what we want. We want pi over 4. So in other words, when you do cosine divided by sine here, you do this divided by this, anything divided by itself should instantly give you just 1, just like here. And that's exactly what we want. We want positive 1. So pi over 4 would do the bill. If you look over here, a similar rule applies here. If you take root 2 over 2 divided by itself, the negative divided by the negative will give you the positive 1. Bingo. So those are the two angles we want, pi over 4 and 5 pi over 4. So back to that example, you will say that for this example, the two angles that we'll need is pi over 4 and 5 pi over 4. All right, piece of cake. Moving on to the next one. For the second one, first get cosine by itself, so you'll add 1 to both sides. So that'll give you cosine of x equals positive 1. So we need to go to the unit circle and figure out where cosine is equal to 1. Okay, so back to the unit circle. Now, if you look just at these angles, well, none of those for cosine is going to equal 1, so all those are out. Same thing here, that's all out. Same here, all those are out. There's nowhere here where cosine is equal to 1. So what am I going to do, Miss Shulin? What am I going to have to look at to find out where cosine is 1? And the answer to that is right here. These right here are the answers for when you're directly on the x-axis. Like if you're at 0 degrees, or if you're at 90 degrees, or if you're at 180 degrees, etc., etc. These are the order pairs you'll look at. So, let's look at this one. Cosine sine. Right here, cosine equals 1. That's exactly what we want. So in other words, the answer would be 0 in degrees or just 0 in radians. Same answer, just for radians, don't put the degree symbol. For here, cosine is 0, we don't want that. Here, cosine is negative 1, we don't want that. Here, cosine is 0, we don't want that. So in this case, we only have one answer that works. We only have that 0 in radians is an answer. Now, some of you may be thinking, well, Ms. Shulin, couldn't I also put 2 pi because that's a full circle? Technically you could if this was a closed bracket. The open bracket on 2 pi is saying no, you don't want to include 2 pi in your answer. So in other words, the only answer it wants is 0. Just wanted to make that clear. Some people have tried to put 0 and 2 pi, but the notation specifically says that since this is an open parentheses, the 2 pi is not included. So I just wanted to clarify that. Moving on to the last example. Let's solve for sine by subtracting it to both sides. So we need to figure out, when does sine equal -1? So if you go to your unit circle, let's look where sine is -1. It's not here. It's not here. It's not here. Ooh, right here, sine -1. That's what we want. So right at 270 degrees, or 3 pi over 2. So then 3 pi over 2. So sometimes you will get 2 angles. Sometimes you will only get 1 angle. And sometimes that 1 angle will just be 0 radians, or just 0. Just wanted to point that out. That can happen. As long as you keep doing the procedure we've been doing, you'll be okay. All right, we're almost done. Moving on to the third part. Now for this one, here I have cosine of x equals -1, and I want to see if 0, 2 pi, and 4 pi will work. So I'm going to do cosine of 0, cosine of 2 pi, and then cosine of 4 pi. And we're going to see if these work. And sure enough, if you plug in cosine of 0, you are going to get 1, which is exactly what we want, so that works. Cosine of 2 pi, that will also give you 1. And cosine of 4 pi will also give you 1. Basically, all 3 of these will work. And some of you are probably recognizing a pattern here. You can probably see that this would also work for 6 pi. It also work for 8 pi, basically just going by 2s. 6 pi, 8 pi, 10 pi, 12 pi, yada, 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 yada. Any type of pi that's a multiple of 2 would satisfy this equation. Now, what if the Hawks program wanted you to label every single one of those solutions in your answer? So Ms. Shulin, that means that the Hawks program, if it wants all those solutions, that means it wants me to put down 0, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, 14 pi, 16 pi, 18 pi. It wants me to keep going? Ms. Shulin, that's going to take forever. We do not have time for that. There has to be a better way to label all those solutions. And it turns out there is. Because again, I don't even have the time to write down all those solutions. I got better things to do. So that's what I'm going to talk about. So let's say you have, say, cosine of x equals 3 pi over 2, and you need to find its solutions. Well, you find out that one of its solutions is right here at pi over 6. So pi over 6 could be a solution. But you know that, like, let's say that's pi over 6. You guys know, just from the previous example, that if I were to add 2 pi degrees to that, that would still work. That would still get me cosine is 3 pi over 2. So in other words, whatever pi 6 plus 2 pi is, which if I do the math in my head, that would be 13 pi over 2. 13 pi over 6. No, wait a minute. 12 pi. Yeah, 13 pi over 6. 13 pi over 6, that would also be a solution. But of course, it doesn't have to be just that loop. I could add a second 2 pi to that, and that would get me a solution. Basically, just add another 2 pi. I could do another full circle. And that'd basically be adding another 2 pi to what I already have. Basically, all of these would work. And again, you're saying to yourself, Miss Shulin, I don't have the time to write all that down. There has to be another way to write this. And there is. A more simplified way to write this down is by doing this. Instead of writing down all these extra 2 pi loops that could give you an answer, you could write this instead. You could write 6 pi plus 2 pi n, where n equals the number of loops that you're doing. Basically, remember when we did all of these loops here? The n is basically going to say, hey, these are the number of loops we did. And this is the notation you would use to label all of those infinite solutions. And that is how the Hogs program wants you to identify those. So, keep that in mind. Something else you will also want to write down. Anytime that you're doing this for sine or cosine, or for any of their twins, you're always going to be doing 2 pi and then times the number of loops, or 2 pi n. If you're using tangent or its twin, you're going to be doing plus 1 pi n, or just plus pi n. Because for them, it repeats every half a loop. So please get that notation down. That for tan and its twin, you'll do plus pi n, and then for everything else, you'll do 2 pi n. That is the notation you use to identify, hey, this means I'm giving you the infinite loops without having to actually write them all down. Please, please, please write this down. You are going to need to remember it. And now that I have taught you that notation, let me show you how to use it. So, let's read the instructions. Identify all possible solutions in the interval 0 to 2 pi and indicate the remaining answers by using n to represent any integers. Basically, the instructions will tell you when to use 2 pi n or pi n. All those previous examples I showed you, we didn't have to use pi n or 2 pi n because the instructions didn't want it. These instructions specifically say, hey, use n, use 2 pi n, use pi n, whichever one you need to use. Basically what I'm saying is, read the instructions, please. I know there might be a couple of you that won't read the instructions and you'll totally forget about the 2 pi n and you'll get it wrong. You know who you are. And I'm warning you now so that you don't make that mistake in the future. Okay, moving on. So back to the problem at hand. I have 4 cosine x plus 2 equals 0. I need to find the solutions. I'm going to first start by getting cosine by itself. So subtract 2 to both sides, and you'll get 4 cosine x equals negative 2. Next, you'll divide by 4. And that will get you cosine of x equals negative 1/2 when you reduce. So now, let's find all the answers where cosine of x is negative 1/2. So let's go to the unit circle. I'm going to erase the notes I put. So all right, let's look at all the cosines. Let's find out where cosine is negative 1. Boom, right here, right at 2/3. Anywhere else? Boom, right here, cosine equals negative 1/2. So that's going to be 4/3. Anywhere else? Nope. So 2 pi thirds and 4 pi thirds. Those are the angles we're going to be using. So, back to here, we have that 2 pi thirds and 4 pi thirds are going to be the angles we're using. But those are only 2 answers. We need to label the remaining answers by using 2 pi or 2 pi n or pi n. And we are going to be using 2 pi because it's cosine. It's not tangent or its twin. So this is how you're going to write it. These are still technically the answers. But for each one, you're going to add 2 pi n, and then comma, 4 pi thirds plus 2 pi n. And that is how you are going to label it in the Hawks program, just like that. Add 2 pi n to each of your answers with a comma in the middle. Just like that. And that's how you label all infinite solutions to this equation. Easy as that. Basically exactly what you're doing, just add 2 pi n. Done. All right, I think we only have 2 more examples like this to cover. So let's take a shot at this one. And again, let's read the instructions, shall we? Identify all possible solutions in the interval from 0 to pi? I need to come back to that one for a second. But read the rest, and indicating the remaining answers by using n. Ding, 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 that's your hint. I gotta use 2 pi n or pi n, depending on the problem. So again, please read the instructions. You'll know when to use 2 pi n and pi n if you read the instructions. But I also want to point out, this is weird. Usually it says it wants to do 0 to 2 pi. Why is it just 0 to 1 pi now? This is another reason why I want you to read the instructions, because you can't always assume it's going to be 0 to 2 pi. These instructions specifically say 0 to pi, meaning if you go to the unit circle, it means that it only wants the answers from 0 to pi. It doesn't want anything afterwards. So in other words, you get to ignore the second half of the circle. I say it's a win. So in other words, we're only going to be focusing on the first half from 0 to pi. And now with that said, let's go back to our actual problem. So we need to first solve for tangent. Let's first add 3 to both sides. So you get 3 root 3 tangent x equals 3. And then we got to divide. Divide the 3 root 3 to both sides. And that's going to give us tangent x. And also we'll see here the 3's that are outside the root, those can reduce, leaving you with a 1 on top. So 1 root 3. So that's our objective. We need to find out when does tangent x equal 1 root 3. Okay, let's go back to the unit circle. So again, we're trying to find when tangent x equals 1 over root 3. And also recognize it's positive. That should be a hint here. And also, you might want to realize that, again, the unit circle only uses cosine and sine. It doesn't use tangent. So maybe we should rewrite tangent. And if you remember, tangent is the same thing as sine over cosine, which does give you 1 over root 3. So in other words, we need to do sine divided by cosine to get 1 root 3. And also notice it needs to be positive root 3. So in other words, if you look over the second quadrant, this one will have you do sine divided by cosine or positive divided by negative, which gives us a negative answer. We don't want a negative answer. So that means anything in quadrant 2 is a no-go. So whatever answer we're looking for, it has to be in quadrant 1. So for each one of these, you'll do sine divided by cosine, and you'll need to figure out which one divides you to 1 over root 3. And I'm going to let you know right now, you do the work and you do all that, you'll find out that the angle that will work is pi over 6. So pi over 6 is the angle you want. So back to our equation. Scroll to the bottom. So using the unit circle, we just got that our answer is pi over 6. Now, some of you are going to press enter, and then the Hawks program is going to say that it's wrong. And you probably wonder why. And if you scroll up, you'll realize you forgot to add the n part. You either got to do 2 pi n or pi n, depending on your trig function. And in this case, it's tangent. And tangent uses pi n. So in other words, take your pi over 6, and you're going to add it to pi n. And that will be the correct Hawks program answer. Again, please take your time. Please read the instructions so that you know when to use pi n or 2 pi n and when not to. I gotta take a drink of water. Okay, so that takes care of that. Now this one I want to talk about real quick, and then that should be about it. Let's do the same thing with this one. Identify all the possible solutions in the interval from 0 to 2 pi. The instructions say the full circle. And indicate the remaining answers by using pi. That's your cue to use 2 pi n or pi n at your final answer. So with that said, let's move on. Let's get the trig function by itself. Add 2 to both sides. So you'll get 2 root 2 times sine. That all equals 2. Then you'll divide by 2 root 2 to both sides. And that will give you sine of x equals, the 2's top and bottom, the 2's outside the root, those can simplify. And that will just give you 1 on top, 1 over root 2. So we just need to find out when sine is 1 over root 2. So let's go to the unit circle. Oh, wait a minute. We're looking for when sine of x is equal to 1 over root 2, right? Do you see anywhere where sine is 1 over root 2? No. Well, shucks, Miss Shulin. Where the heck is it? Just going to let you know right now, 1 root 2 is on the unit circle. The thing is, it's not rationalized. So go ahead and take root 2 top and bottom to this. Multiply the top, you'll get root 2. Multiply the bottom, root 2 times root 2 is root 4. Simplify that, you'll still get root 2 on top, but root 4 on bottom is a perfect root, which becomes a normal 2. Okay, Miss Shulin, now I see where you're coming from. There's what I'm looking for. So sine is going to be root 2 over 2 at pi over 4, and then over here at 3 pi over 4. And if you look at all the others, nope, those are the only 2 that work. So back. So back to this answer. Our 2 angles that work are pi over 4 and 3 pi over 4. Wait a minute, don't press that submit button. Don't press enter, because I feel like I'm missing something. Am I missing something? Oh, wait, yes, I am. The instructions told me to use 2 pi n or pi n. And specifically, since we're using sine uses 2 pi n. So, formally, we will write this as pi over 4 plus 2 pi n, comma, 3 pi over 4 plus 2 pi n. That was a little janky. And that is what the answer will look like in the Hawks program. So please read the instructions and you should be able to answer these just fine. Now the last slide, this one is kind of an awkward problem. I mean, there is a way to solve it, but it's kind of convoluted. And also, I can guarantee you this problem, it will not be on the online test. So if you really, really, really want me to teach this problem to you, you can email me. If not, there's only going to be one of these on the homework. So I would actually recommend, if you're not interested in learning how to solve this problem, just take the strike, put in no solution, and just see what happens. So that's my advice for that problem. But if you really, 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 really want me, you want me to teach it, please email me, and I will explain it. So, but besides that, you guys have all the tools and resources you need. You are officially ready to do the online homework. Have fun with that. And if you have any questions or concerns, you know my email. You have a good one.